In this problem, we're going to solve the following inequality: x minus 3 over x plus 1 being greater than 0. So what we're going to do, we're going to check that we have all the terms on the left-hand side and we have a single fraction on the left-hand side. So this is already done in this inequality. So what comes next, so we think of the graph of the left-hand side. And this inequality being greater than 0 means that the graph of y equals x minus 3 over x plus 1 is exactly above x-axis. Again, greater than 0 means that the graph is above x-axis. So we're going to find x-intercepts and vertical asymptotes of the graph of this function and use that to solve inequality. To find x-intercepts, we set the entire expression equals 0. But then the fraction is equal to 0 only when the numerator is equal to 0. So to find x-intercepts, all we need to really do is to set x minus 3 equals 0. And that gives us x equals 3 for the x-intercept. So then for the vertical asymptotes, those are the points where denominator is 0. So set x plus 1 equals 0. We get x equals -1 for the vertical asymptote. So now we make a graph out of this. So 3 is the honest x-intercept, and then -1 is a vertical asymptote. So I'm going to put a dashed line through x equals -1. And now we just use the test points. So I use -2, which is to the left of -1, 0, which is in the middle, and +4, which is to the right. So y at -2 is equal to -2 minus 3 over -2 plus 1. When we calculate this out, we get +5. Then y at 0 is equal to 0 minus 3 over 0 plus 1. We get -3. And then y at 4, that's equal to 4 minus 3 over 4 plus 1. That gives you 1/5. So now we're ready to make interpretations. So where we get positive numbers, that means the graph is above x-axis. So at x equals -2, we get the value 5. That means that the graph is above. We got -3s for the x equals 0. So the graph is below there. And we get 1/5 for x equals 4, so the graph is above. So I'm going to put that onto the sketch. So the graph will be above to the left of -1. It will be below x-axis between -1 and 3, and it's going to be above to the right of 3. Now looking back on the inequality, we're looking for the intervals where the graph is above x-axis. So it's going to give us the interval from 3 to infinity and the interval from -infinity to -1. So the graph of y equals x minus 3 over x plus 1 is above x-axis on interval -infinity -1 joined with 3 up to +infinity. So the solution set to original inequality is exactly the same combination of two intervals: -infinity to -1 joined with interval from 3 to +infinity. In this example, we're going to solve non-strict inequality, where we have x minus 3 over x plus 1 being greater or equal than 0. So to get started, we double check that all the terms are on the left-hand side and everything is combined into a single rational expression. So that was already done. And now we think about this inequality in terms of the graph. So since we have inequality greater or equal than 0, that means that the graph of y equals x minus 3 over x plus 1 is above or exactly on x-axis. So to talk about the graph, we solve the equations to find x-intercepts and vertical asymptotes. So for x-intercepts, we essentially focus on the numerator. So x minus 3 equals 0 gives us x equals 3. And for the vertical asymptotes, we get x plus 1 equals 0, so x is equal to -1. So we graph the situation using test points. So we have the graph, -1 is the vertical asymptote, +3 is the honest x-intercept. And I'm going to put vertical dashed line through -1. So then we use some test points. -2, 0, and 4 are the good test points. So calculate y at -2. That gives us 5, and then y of 0 gives us -3. Y of 4 gives us 1/5. So since we get 5 here, the graph is above. Since we get -3 there, the graph is below. Since we get 1/5 there, the graph is above. So putting that on the picture, we have the graph being above, below, above, if you go left to right. So since we're looking for the places where the graph is above or exactly on the x-axis, so we're going to have the graph being above to the right of 3, and it's also above to the left of -1. So for the intervals, we have that the graph of y equals x minus 3 over x plus 1 is above or exactly on x-axis on the interval -∞ to -1, with parentheses next to -1 because it is a vertical asymptote. The graph doesn't even exist there. Together with interval from 3 to +∞, this time 3 is included because it is an honest x-intercept. So the difference between those 2 points is that -1 is a vertical asymptote and +3 is an x-intercept. So having said that, we can state the solution set to the inequality. And it's gonna be exactly the same two intervals. So it's interval from -∞ to -1 with parentheses, with interval bracket 3 up to +∞. So that's the solution set to this inequality. So in this problem we're going to solve the inequality x plus 2 over x minus 4 being greater or equal than 1. And to get started, we move all the terms to the left-hand side, combine the left-hand side terms into a single fractional expression. So if we move 1 over, we end up with x plus 2 over x minus 4 minus 1 being greater or equal than 0. Then do common denominator, which is going to be x minus 4. We're looking on x plus 2 over x minus 4 minus 1 times x minus 4 over x minus 4 being greater or equal than 0. So doing the subtraction, we end up with x plus 2 minus parentheses x minus 4, all of that x minus 4 greater or equal than 0. Then distributing the negative sign here, we end up with x plus 2 minus x plus 4 in numerator. And combining like terms, we end up with x minus x cancelling out, and then 2 plus 4 is 6. So the simplified form of this inequality is 6 over x minus 4 is greater or equal than 0. So it means that the graph of y equals 6 over x minus 4 is above or exactly on x-axis. So, well, what we need to determine where the graph is above or on x-axis is to find x-intercepts and vertical asymptotes. For x-intercept, we set numerator, which is 6, equal to 0. And that has no solutions, so there are no x-intercepts. For the vertical asymptotes, we set the denominator, x minus 4 equals 0. And that is going to give us not x equals 4, it's going to give us x, well, it's not x equals 0, it's going to give us x equals 4 for the solution set. So now we'll make a picture. Let me put a vertical bar. So here is a picture. So we have vertical asymptote at x equals 4. And I'm even going to draw a vertical line through that. And we're going to use a couple of test points. So there is x equals 0 and x equals 10. So at x equals 0, calculate y of 0. So we're going to put x equals 0 into 6 over x minus 4. We end up with 6 over negative 4, that's negative 3/2. So it's a negative number, that means that the graph is below x-axis. And I'm going to put the label that the graph is below x-axis there. Then at 10, we're going to put x equals 10. So we end up with 6 over 10 minus 4. So this is 6 divided by 6 and gives us positive 1. So the graph is above on that interval. So now, since we're looking for the places where the graph of the left-hand side is above, or exactly on x-axis, we have this one interval to the right of x equals 4 as the place where the graph is above x-axis. And the solution set will be the interval from 4 to positive infinity with parentheses next to 4, because x equals 4 is a vertical asymptote, and the graph doesn't even exist at that point. So that's the answer to the original inequality, interval from 4 to positive infinity. Now in this example we're going to solve inequality 1 over x minus 2 being less than 2 over 3x minus 9. To get started, we're going to move all terms to the left-hand side and combine everything into a single fractional expression. So if we move the right-hand side terms over, we end up with 1 over x minus 2 over 3x minus 9 being less than 0. The common denominator is x minus 2 times 3x minus 9. So we're going to multiply the first fraction by 3x minus 9 and the second fraction by x minus 2. So when we're done with combining, we're going to end up with expression 1 times 3x minus 9 minus 2 times x minus 2, all of that over x minus 2 times 3x minus 9. So now all we have to do is to distribute everything in numerator and simplify that. So distributing 1, we get 3x minus 9. Distributing negative 2, we end up with negative 2x plus 4. And now combining like terms, we end up with x minus 5 in numerator. And we have exactly the same terms in denominator, x minus 2 times 3x minus 9. Since we solve an inequality less than 0, it means that the graph of y equals x minus 5 over x minus 2 times 3x minus 9 is below x-axis. So now we start looking for x-intercepts and vertical asymptotes. For the x-intercepts, we set x minus 5 equals 0. So set x minus 5 equals 0, and then that gives us x equals 5. Secondly, you set denominator equals 0 to get vertical asymptotes. So it's x minus 2 times 3x minus 9 equals 0. So that's going to give us x equals 2. And 3x minus 9 equals 0 gives us x equals 3. So now it's the time to sketch the graph. So we have the single x-intercept, x equals 5. And then there are two vertical asymptotes, x equals 2 and x equals 3. So we're going to use vertical asymptotes here. And then we're going to pick the test points. So to the left of 2, we're going to pick x equals 0. Between 2 and 3, x equals 2.5. Between 3 and 5, x equals 4. And to the right of 5, x equals 10. Now we're going to calculate y at each of those test points. So y at 0 gives us negative 5 over negative 2 times negative 9. So that's negative 5 over 18. So it's a negative number. The graph will be below on that interval. So hence this word below. Then at 2.5 we crunch the numbers and we end up with a positive number. So the graph is going to be above x-axis there. So between 2 and 3 the graph is above x-axis. Then at x equals 4 we crunch the numbers and we end up with negative 1/6. So that's a negative number. The graph is below x-axis. At x equals 4, so the graph is going to be below x-axis between 3 and 5. Likewise, at 10, we figure out all the terms, and we end up with some positive number. So the graph is above, so at x equals 10, and so the graph will be above everywhere to the right of x equals 5. So now, remember we're solving inequality less than 0, so we're looking for the places where the graph is below x-axis. And that's the interval from -infinity to 2 and interval from 3 to 5. So the solution set to that inequality is interval from -infinity to 2, joined with interval from 3 to 5.